Let's see if we would get a decimal. Three sides of a triangle are 12, 15, 18. A similar triangle has its shortest side as 3. So they use the word similar, so that definitely means that everything is in proportion because they're just directly telling you that they are in fact similar. We just don't know how much similar yet. We could easily figure it out. So I like to draw two generic triangles. Actually, that's not that good. How about that? Because we know one's bigger, one's smaller. Again, you don't need to be drawing these to scale, you don't, and so forth, as long as you kind of get the gist of it. 12, 15, and 18. And then the other triangle has the shortest side as 3. So I want to write it so, in a fact, that they are corresponding to each other. So if you look right here, the shortest side to the big triangle is 12. That means the 3 must correspond with that 12. It cannot correspond with the 15 and 18. So I would put the 3 here because these two sides, assuming I haven't done any rotations or reflections, these two sides are the ones that are corresponding to each other. So then they're asking, what is the measure of the longest side of the triangle, of the smaller triangle? Well, the largest side is 18, and the largest side of this triangle would be this bottom one right here. So you need to ultimately figure out what was the scale factor, what number am I multiplying into 12 to get 3. And it looks like you've done a dilation of 4, or you've divided by 4, a dilation of 1/4, however you want to think of it. It's a dilation of 4 if you're going this way, dilation of 1/4 if you're going the other way. Which makes it so that all you got to do is take 18, multiply by 1/4. 4 does not go into 18 evenly. That is going to be a decimal, something 0.5 is my guess, like 4.5 or something like that. So yes, you do get a decimal for this one. So not that strange. That's not a bad side. Looks good to me. So hopefully that helps. All right. Tomorrow, actually, you have 2 more days. You guys could ask questions on weeklies, because you could ask me on Friday too, the day it is due, because there's no technical due date or time when it is due, as long as you get it in sometime on Friday. A lot of people get it in the evening, which is fine by me. But we're gonna continue with some of the work that we were doing yesterday. We did a lot of the algebra practice, and we're going to see some of that come up today. And we have lots of different rules that we're going to be going over. The good thing, as I say, there's lots and lots of rules with these circles. One of the good pieces of information is that some of the rules, they're mostly similar to each other, which is good. But it does take some time to get used to all of them. All right? So we're going to jump right into, it was 18 times 1/4. Yes, I got 4.5. You divided. Well, 18 times 1/4 is the same thing as 18 divided by 4. They're going to be the same thing. As long as you get 4.5 as the answer, yes, dividing by 4 or multiplying by 1/4. Same thing. So 4.5 should be the answer. We're going to go to these rules. So we did interior intersections, where we are able to calculate the angle inside of a circle when two secants or chords intersect each other, where we're going to take the two corresponding intercepted chords and divide by 2, and we can get the angles that are inside the triangle. It just matters which angles you're looking for and so forth. Big thing to keep in mind is angle 1, the intercepted arcs are the yellow ones right here, and its vertical side over there. If you were looking at angle 2, you'd be using those purple arcs instead. So it doesn't matter which arcs you use. And another thing is, these are not the center of the circle, so central angle rules are not in play here. Unless you know they come from the center, then it's a lot easier. But this is assuming that this angle is not in the center of the circle. We can use these calculations right here. You add up the two arcs, the corresponding intercepted arcs, and then divide by 2. And that's what we practiced yesterday. We're going to continue practicing that today. So in number 3, they're asking for the measure of y, w, x. And let's keep in mind a few things. Let's look at the angle that they want. Notice that angle right there is not part of the intercepted arcs. If you were to do the rule that we know, which is add up those two arcs, divide by 2, just note that it's going to give you these two angles, which is fine. Knowing those two angles is great, because if you know one of them, you could easily take the supplement, the linear pair, to figure out the angle that they actually want, which is this one right here, where I put the question mark. Just note that the rule will not give you directly the answer. We've seen this time and time again. There's multiple steps. So we're going to apply the rule. 43 plus, what was the other one? 81 divided by 2. Just note what angle this is finding. I'll label it as angle 1. That this is going to give me angle 1. Not the answer. But that's fine. 43 plus 81 is going to be 124. Cut that in half. This calculation should be 62. We go to the diagram. That definitely makes sense depending, on the size of this angle. That's 62, and that's 62 as well. But that one additional step, we do need to take the supplement of that because we have a linear pair here, so we just have to do 180 minus 62 for our final answer, which is going to be, I think that's going to be 118? Yeah, 118. So angle y, w, x equals 118 degrees. So just be aware of what the rule, adding these arcs and dividing by 2, what angle it's going to give you. Then label in the diagram so you can see where you can go from there. Because it is very unlikely, most questions are not going to be one step. Most questions are going to be more along the lines of this, or even harder. All right, now in number 4, they're asking for the measure of arc LK. Which, let's go to the diagram. Where's LK? It's right here. This is the first time we're looking for an arc rather than an angle. So we do have to work a little bit backwards here. Because remember what the rule says. It says if you add up the two corresponding arcs, which would be 74 and this unknown arc, you'd have to add those together. If we add those together, we have 74 plus an unknown. We don't know arc LK. If we divide it by 2, we know we're supposed to get those inside angles, which in this case is 62. So you'd set the whole thing equal to 62. And then we're going to solve from here. You put the 62 over 1, and the best thing to do, just like when we were doing that algebra review, cross multiply is going to be your best bet. So we're going to double 62. That's going to give us 124, which is equal to 74 plus arc LK. It's a bad equal sign. There we go. And then last step, just subtract both sides by 74. Subtracting 74, is that 50? I think so. So arc LK, the measure of arc LK, is equal to 50 degrees. So there's obviously a chance you have to work backwards. Instead of finding the angle, they can give you the angle, then you just work backwards based on that. All right, let's keep on going. Number 5. They want the measure of arc CDE. So CDE, they are using 3 letters there, so make sure you follow those letters. So starting from here, there's C, then go to D, and then end at E. So I'm guessing that this is some kind of major arc, so it's probably greater than 180 degrees. It doesn't have to be, but it is likely. It might be pretty close to 180 degrees. They give us the angle, 128. Always recognize, is that the correct angle that you want? You have to take a linear pair. In this case, that's good because it is the intercepted arc, so that's 128 is good. And then, is the 73 good with where it is? It is. So we're ready to just plug everything in. So 73 degrees plus arc CDE divided by 2 is equal to 128 degrees. Throw it over 1. We're going to cross multiply again. So we got this one. We got to double 128. We double 128, that's going to be 256. Equals 73 plus arc CDE. And then we just got one last step. Subtract 73 from both sides. And kind of as predicted, we actually do get a number greater than 180. Not much greater, but we do get that the measure of arc CDE, when you subtract 73, we get 183. Which makes sense. One more. At least one more with this rule. Find the measure of arc QT. If you look across, the intercepted arc on the other side is 95, so those two numbers are good. But now you probably realize that 79 is not directly useful to the rule. The angles that you really want are these two right here, these two vertical angles, because those are the intercepted arcs. Those angles are associated with those arcs. So we do have an initial first step, which is what is the linear pair, the supplement of 79, which is 101. So 101 is the number you want to use. 101 is the number you're going to set the two arcs divided by 2 equal to. So it's 95 plus QT divided by 2 equals 101. And I always just throw it over 1 so I can cross multiply. So that times 1, and that times 2. So we get 202 equals 95 plus QT. And then it's 202 minus 95. So we get 107 is equal to the measure of arc QT. And that is interior intersections. That is interior intersections. When the angle is inside the circle. Now we're going to jump to a new rule. Which are called on the circle intersections. And this one is going to go back to the use of a tangent. But instead of a tangent and radius, so we're going to have another tangent rule. This one says if a secant, it could be a chord too. It does not need to be, it doesn't have to be a secant. It can be a secant or chord. And a tangent, that has to be true. No, if you don't include the m in front of it, I mean, I'll know what you mean, because units, again, are not important. That's something we've done all year. We've never worried about the little m. It doesn't matter. Just know specifically, if you're using m with the measure of, usually you mean the degree measure. So it's very common you see it with angles. I'm just including it with my arc, so when you see it, you know what the degree measure. If you don't see it, it's typically a length. I know I was a little sloppy with it here. Like I technically should include it here. If you don't, you're not going to lose points. I'm not being picky with it at all. I'll know what you mean. Based on your work, I'll know if it's a length or a degree measure, based on reading your work. So you don't have to worry about like those little technical details. But that's a really, really good question. So again, going back to this definition, secant or chord doesn't matter. In this case, we're talking about this line right here. It doesn't matter if that were a chord or a secant. But the other one that has to be true is the tangent. One of these lines has to be tangent for this rule. If they intersect at a point of tangency, then the measure of each angle formed is equal to half the measure, which is basically, it's an inscribed angle in a way. It's not exactly an inscribed angle, but it's pretty close in terms of how the rule is going to work. Because these angles, they're not truly inscribed, because an inscribed circle would go onto the circle, but these angles lie outside the circle as well, but the rule is almost exactly the same. So what does that really mean? It means that if this arc right here, let's say BCA, if I were to just say this were 200 degrees, just like an inscribed angle, if I cut it in half, and I have a chord secant intersected with a tangent, that means this angle is 100 degrees. That's the rule. Pretty simple one. And then on the other side of that, you actually would know the other angle. This would have to be 80 degrees, and then the other arc would have to be 160 degrees. So technically with this, if you know that a tangent and a secant or a chord are intersecting each other like this, if you know one angle, usually you can figure out the other three pretty easily. Other two arcs or angle. So over here, angle 1, the measure of angle 1 is 1/2 the measure of arc AB. Or arc AB over 2. If some people like to read it like this. They just mean the same exact thing. However you want to read it is up to you. But you're just taking the arc, cutting it in half. And you can, of course, go backwards. You can double the angle to go the other way. Will it be wrong if we didn't? No, it would not be wrong. At least, I'm still under the assumption that if you were taking the Regents, and if you were taking the Regents, whoever is grading it would never mark you wrong, ever. It is not one of the things we are required to look at. It is different, when I grade a physics Regents, all of a sudden it does become different. You can keep that in mind. But for the sake of geometry, you never have to worry about that kind of stuff, Paige. And then for the measure of angle 2, it's going to be 1/2 the measure of arc BCA. So I do have to use 3 letters for this one because it is a major arc. And I'll include, just for anyone who likes to see it that way, doesn't matter. So you got 3 examples. They're going to go by pretty quick because it's a pretty easy rule. Number 7 asks for, find the measure of angle DEG. DEG, right there. So you have the arc, the big arc right there is 308. Very simple. Just cut it in half. So 308 divided by 2. The measure of angle DEG is equal to, it's going to be 154. Just like an inscribed angle, basically the same rule, relatively easy. Find the measure of angle DBC. There's 2 things you can do here to figure it out. You can go in either direction. Option number 1 is you can figure out angle ABD by cutting the 192 in half. You can also directly find arc DB by subtracting 192 by 360 and then dividing that angle or the arc measure by 2. No matter how you do it, it's going to be 2 steps. I'm going to just find the angle first. So it is going to require 2 steps. I'm going to take 192. I'm going to divide it by 2, and then that's going to be 96. That's this angle right here. That's not the answer, because I do want angle DBC. So we just got to take the linear pair of that, which would be 84 degrees. So the measure of angle DBC equals 84 degrees. And the last one on the page, number 9, find arc XY. Arc XY is this tiny little arc right here. So what I would do first is find the angle right next to it or right above it, which would be 29 degrees. Then all you need to do, you're going backwards now, like an inscribed angle, just double it. So arc, the measure of arc XY is equal to 58. As I've mentioned in the past, and I will probably mention again in the future, the rules they're not hard. You know, you can see, you guys can all divide by 2 and double things. It's when this situation naturally occurs, are you going to remember this specific rule? Because we just went over another one, and at the beginning of the week, I just went over half a dozen other different rules. And now when we flip the page, we're going to have 3 new ones. They're not terribly difficult, but it just keeps piling on with information. It's an information overload that it's just, can you recognize all the different rules? So this one is going to be exterior intersections with angles. So in the previous page, with all the chords and or secants, all the angles that were in question were inside the circle or on the circle with this one down here. But for the most part, all the angles were out here. For this one, the angles in question are going to be outside the circle. So there's going to either be secants or tangents that are occurring. And although I say that this is 3 different rules, it's really the same rule every time, but it is different from the previous one. And you'll kind of see what I mean by that. So we can calculate the measure of angle A by taking, again, those corresponding arcs that are related to A. So there's 2 intercepted arcs when it comes to angle A. The 2 intercepted arcs are BD and CE. So you don't want to use the other 2, but those 2 could be helpful in figuring out the 2 yellow ones that I highlighted. You're going to take the larger arc, CE, and you're going to subtract the smaller arc, BD. And you're going to divide by 2. That's very similar to what we were doing yesterday and at the beginning of today. But you'll notice the big difference is subtraction. And that's why these rules you can confuse them so easily, because you come up to a problem, you're like, oh, is this an addition one or a subtraction one? It really depends on where that angle is. But the good thing, because there's going to be 2 more, it's always the same pattern. It's always larger arc minus smaller arc, then divide by 2. That is going to be the rule for all of them across the board. You're always going to take the biggest intercepted arc, you're going to subtract the smaller one, divide by 2, and that's going to give you the angle that's outside of the triangle, which in this case, when we do this procedure, we would get the measure of angle A. But you got to remember it's subtraction, not addition, because it's not inside. So using the same rule, it's going to be the same one. The larger arc minus the smaller one. So in this one, the intercepted larger arc is this one, the furthest one away from the angle, which would be arc BD. Or just call it arc BD. We're going to assume it's smaller than 180 because we don't know if it's a major arc or not. So we'll just call it BD. Then the smaller arc, which is BC. And then divide by 2. So it's the measure of arc BD minus the measure of arc BC divided by 2. There we go. Again, big arc minus small arc divided by 2. And the last one's going to be the same exact thing. It's just each rule, one is just with 2 secants, one is a secant and 1 tangent, and then the last one is just 2 tangents. And 2 tangents is honestly probably a little bit easier because there's only 2 arcs in the circle. You can't even choose an incorrect arc. You have the big arc, you have the small arc, which constitutes the entire circle. So technically, you could figure out angle A if we just give you the measure of one of the arcs, because you could easily figure out the other arc by subtracting from 360 and then finding the measure of angle A. But it's still going to follow the same rule. Big arc minus little arc. So the measure, this one is a major arc, so this one's going to be arc BDC minus arc BC, all divided by 2. So those are the 3 rules, 3 different scenarios, but they're all similar. Each diagram's slightly different, but it's really just following the same pattern. Big arc minus little arc, divide by 2. But make that mental note that this rule is different from this one. This is the addition one when that angle's on the inside. When those angles are on the outside, it is subtraction. So with the subtraction one, the order does matter. If you flip the order, the only thing you're going to notice is you're going to get negative angles. If you ever get a negative angle when you're doing these rules, just be mindful. You probably just flipped them. And, you can just double check it, flip them over, and you should be fine. Let's start applying the rule. So we're always going to do the same thing. Big arc minus little arc. We just have to kind of, assemble the diagram, make sure that we have the right information. Make sure you have the correct intercepted arcs. In number 10, we have that. We have arc JN, which is 140. We have KM, which is 66. And they want us to figure out angle L. So we can just directly plug in 140 degrees minus 66 degrees. We're going to divide it by 2, and that's going to be the measure of angle L. So 140 minus 66, that's 74. Still have to divide it by 2. We divide it by 2, you get 37 degrees for the measure of angle L. Which looks pretty reasonable for the size of that angle. Number 11. Doesn't matter that the diagram is now a secant tangent. It's still going to be the same rule. It's still just going to be big arc minus little arc. You just got to make sure that you use the right arcs. So in this case, we have to use arc, this one right here, from D to A, which is not labeled right now. And then we also need to use this 62. So we got to figure out, well, that 88 does not get plugged into this, big arc minus little arc. But that 88 will help us figure out the value of the yellow arc, because this arc from D to A, that arc right there is, well, whatever 62 plus 88 is, which would be 150 degrees. 150 degrees is the sum of the 88 and 62. The rest of the circle is just the yellow arc. So we can just subtract that from 360 degrees, which we get 210. That's the value of the yellow arc. So you might have to, assemble the diagram, just like always, to get the values that you need. Now I have the ones I need. Big arc, 210, minus little arc, 62 degrees, divided by 2, and that's going to be the measure of angle B. Or ABC, same thing. So 210 minus 62 is 148. Still need to divide that by 2. We get 74 degrees for the measure of angle B. And that one utilized a secant and a tangent, because the first one was 2 secants, and then the bottom one is just going to be 2 tangents. So we'll see how we can figure this one out. They want the measure of angle PQR, but they only gave us one arc. But I did say they only need one piece of information, especially if it is 2 tangents. If the entire arc PSR is 313, that means, well, what is the value of the smaller arc that we need? Well, it's just whatever 313 is subtracted from 360 degrees, which would be 47. So arc, the green arc, is 47. And then you can just jump right into the rule. 313 minus 47 divided by 2 is angle Q. So 313 minus 47 is 266 divided by 2. And obviously you know you need to divide by 2 because you can't have an angle that's 266 degrees. But when you cut it in half, you get 133 degrees, which seems pretty good because it's definitely a pretty large obtuse angle. But notice I don't have to keep going back and forth to the diagram and say, all right, it's 2 tangents. Which rule do I use? It doesn't matter. As long as we're following this rule every time. Big arc minus little arc divided by 2. So even though I say, yeah, it's 3 rules, it's really not. It's really the same rule just being applied in different ways. Oh, the truck backing up? That is, yeah, that's across the street. And it's very loud. If that's the noise you're talking about. Number 13. The measure of angle BCD. So let's see, where's BCD? So that is angle C. But we do need to kind of figure out the correct arcs. 67 is good. That's the big arc. That's the correct arc we need. But we also need this tiny little arc right here, this one that I've highlighted in yellow. So I do need to kind of use this 94 and figure out what is it going to be. Well, it looks like they've labeled the center right here. That's great. Because if that's the center, that's a semicircle right there. That's 180 degrees. If that's a semicircle, the semicircle on the other side, this entire circle, is also 180 degrees. So that we can use to figure out the little arc. If the other 2 arcs are 67 and 94. Because 67 and 94, I add them together, you get 161. So that's from here to here. That's 164. So if I take 180, subtract 164, that tiny little arc in there must be 16 degrees. So this tiny little arc is 16 degrees. And now I can go right to the rule, big arc minus little arc, and divide by 2. So let's do that. 67 degrees minus 16 degrees divided by 2 is angle C. It doesn't look like we're going to get an odd number, so we're probably going to get a decimal here, which is fine. Unless, no, I calculated something wrong, didn't I? I think I did. I don't think this is 164. I'm going to recalculate that. It's 161. Which makes this 19 degrees. So that makes this 19 instead of 16. That makes this 19. And we will not get a decimal. We'll get, yeah. It is 19. So 67 minus 19 is 48. So it should be 48 divided by 2, which is 24 degrees for angle C. Which is nothing saying you couldn't get decimals, but I just calculated. I just calculated incorrectly. But you absolutely could get decimals for these. We got 4 left on this page. I only got about a minute and a half left. But I am going to stop there. I think we have a pretty good idea on the rules. We'll probably start. I'm not going to do all 4 tomorrow. I'll probably do like 1 or 2 just to refresh the rule. Because when we flip the page, that's where that algebra is going to start coming in, and all the rules are kind of mixed up. You have interior angles, you have the rule that we went over today, then you have exterior rules, you have all, it's all mixed up, and it's going to get a little harder because there's going to be more algebra. So that's kind of what we're going to lead into tomorrow. No new rules, so we can just practice the ones that we know already and that we've just learned in combination from yesterday and today. But then on Friday, we might go over something new. But there's plenty of practice that we have that we can go over. Help with weekly question 1 and 2. Is that what I'm hearing? But we are done. If you want to stick around and watch these weeklies, that's fine by me. We need help with number 1. Is that what I'm... I'll take a look at 1. I got a few people saying number 1, which is a good one because it's a circle one, and that's the unit we're doing. See you later, Kieran. The measure of angle KJL is equal to 9x plus 6. So where's J... or KJL? That's this angle in here. And the measure of KLJ is 3x plus 36. Find arc KL. You're welcome, Ty. So one of the things I noticed in this diagram is immediately the fact that this is a right triangle. And I know it's a right triangle because angle K is inscribed to a semicircle or a diameter. Because this is a diameter, that makes this a right triangle. And in a right triangle, the two acute angles must add up to 90 degrees. So my first step would be, well, 9x plus 6 plus 3x plus 36 equals 90 degrees. That should be step number 1. And just by looking at the values of x, I think these numbers, I don't think it's going to be that nice to scale, but we'll see. You combine like terms, you get 12x plus 42 equals 90. And you get 12x equals, I think that's 48. And then x equals 4. Because then they ask you to find the value of KL, and yeah, I'm immediately seeing that Maybe it's not that bad. I don't know. If you want arc KL, you're going to have to plug into angle J. We plug in 4 into here. We get 9 times 4 plus 6, which is 36 plus 6, which is 42 degrees. It's actually not that bad. I think it's okay. It's not great, but that angle in here being 42 degrees it's fine. But that's not the answer, because remember, it is an inscribed angle. You are going to have to take one additional step, and what's the relationship between the angle and its inscribed angle? You're going to have to double it. You double it, you got your final answer, which I think is fine. It's a little small. It's not great drawn to scale, but it's fine. So if that confused you, I guess I could understand it, but overall I think it's fine. Any other questions? Gavin said number 2. Number 2, you're going to have to do, it's a right triangle cut with an altitude. So as soon as I see this, I have a few things in my mind. That's rule number 1. That comes up with this diagram almost all the time, as well as Pythagorean theorem, a squared plus b squared equals c squared. The a's in these formulas are different though. This a is the altitude. This is x, this is y. So x is 4 if I'm using that rule. And I'm going to want to find altitude BD. So you use the first formula. BD squared equals x times y, which is 4 times 8, which is 32. Then you got to square root both sides. BD, because you got to square root both sides, is equal to the square root of 32. That's not the answer, though, because that's BD. They want the length of BC. But I can now use Pythagorean theorem down here with this right triangle right here and find the hypotenuse that way, because this is the square root of 32. So I'm just going to plug in the Pythagorean theorem. I got the square root of 32 squared plus 4 squared equals whatever BC squared is. So now just plug in the Pythagorean theorem and then tell me what you get. I think you should get square root of 48. And you do have to put that in simplest radical form, because the square root of 48 can be broken down in the simplest radical form. Last one on the second page, how do I find the area of a triangle? I know 1/2 base times height, but how do I find the height? All right. So 1/2 base times height. When we say height, we really mean altitude. The word height is just a synonym for the word altitude. The dotted line that I've highlighted there is the height of the triangle. We should know the base, though, I think. Yes, we know the base. We know the length of FG. A lot of this is actually a circle question. The radius to this circle is 8.5. CK is also 8.5 because they're both a radii. So if I swing up to the top of the page, this is 8.5, this is 8.5. There's your base right there, 17. So if you're looking at 1/2 base times height, you got the base of 17. However, you've asked, how do you find the height? I like this question a lot. Well, here's a right triangle. You can't do Pythagorean theorem because you only have one side. But you have an angle and a side. So this is actually, in order to find the height, you SOHCAHTOA. You have a right triangle, you have an angle, you have a side, jump right to SOHCAHTOA to figure out the height there. I think you're going to have to use tangent. Don't be surprised because you're going to be taking the tangent of 47. You are going to have an irrational number here, so you are going to have to probably round it the best you can, but that is how you find the height to that triangle. Once you have the height, then you can do 1/2 base times height. Just be aware that you are going to get a decimal number. This problem does work out. It's not that nice in terms of the numbers. So keep that in mind. Don't think you're going on the wrong track because these numbers are going to, especially the height of that, is going to be, crazy. Also, you have a half circle down there. That's also going to be irrational because you're likely doing pi r squared and then cutting it in half. Just keep that in mind. That's how you'd find the height, though. So hopefully that answers your question on how to find the height. If SOHCAHTOA, especially if SOHCAHTOA didn't cross your mind. That's why they gave you the 47 degrees. You can't use a squared equals x times y for this question right here. Reason you can't use a squared equals x times y. Remember, that formula is only useful if you know the big triangle's right triangle. If this were a right angle at angle E, then yes, I could say, yeah, you could use that formula. But we could actually justify angle E is not a right angle. Because this has to... actually, do we know it's isosceles? Trying to think if we know this is isosceles. Excuse me. Yes, we do, because we know these angles are congruent because we have the two 90-degree angles. So this actually is an isosceles triangle. 47 plus 47 is 94. Angle E, the entire angle, is 86. Therefore, a squared equals x times y does not work for this question. Can't use that. You're going to have to use... So, tan of 47, tangent of 47, tangent opposite and adjacent. So tan of 47 equals opposite, which is ED, over adjacent, 8.5. Yeah, that's how I would find the height or the altitude to this triangle.